I want to go over this quiz real quick for you guys not here. Now, if we're looking at this, all right, some people were missing this question because when I asked you, for example, for a max or min, you were thinking that the max or min of f of x were here, here, and here, which is not actually true. Remember, you're looking at the graph of f prime of x, all right? So this is the graph of the derivative. And remember, my horizontal tangents, all right, remember the horizontal tangent means you have a slope of 0, and in this case the slopes of 0 are located on the roots of this graph. So all of the horizontal tangents are located where the intercepts, x-intercepts happen. If you're looking at the derivative graph, remember that. All right, you cannot forget that. It's essential. Now, some people, for example, wrote only one answer, like they only wrote a 0 here. Right, because they were looking at this, it's like, oh, you have a horizontal tangent. Okay, it just happens to be that this is touching also, right? This is a root, this is a double root. So even this one, has a horizontal tangent, but it has nothing to do with the shape of this. It has more to do with the fact that this f prime of x equation is actually touching that x-axis, which means that you have a horizontal tangent, all right? So again, just to simplify everything, if you're looking at the derivative graph, your horizontal tangents are located where your curve is touching the x-axis. Everybody clear on that? And a lot of you did very well on that, but some of you were just awful at that. Okay, now if I'm looking for a max or min, don't forget this. Again, this is essential. It's never going to go away. All right, it will be in this class pretty much the rest of the year. If I ask you for our maximum, right, again, I'm not asking you for a maximum on this graph. I'm asking you for the maximum on f of x. And remember, you cannot see f of x. So you have to go off your derivative graph and you have to think, okay, how can I find the maximum? Remember that your maximum is going to be located where you go from a positive derivative to a negative derivative, right? Because if you go from positive to negative, that means that on f of x, you went from increasing to decreasing, which will create a max. Again, you went from increasing to decreasing. So this is a max. And it turns out that this is a max also. Excuse me, is this a max? No, this is a minimum because you went from negative to positive derivative, right? So if you went from negative to positive, what does a negative derivative mean? That means you're decreasing on f of x. And if you have a positive derivative, that means you have an increasing function. So you went from decreasing to increasing, which will create a minimum. All right, and I'm going to go over one example in the review so you can see sort of what I'm talking about. Now, the very last question on here is asking at the point x is equal to negative 2, is f of x increasing or decreasing? All right. Now, what you do, if you have the derivative function, is go to that negative 2, x is equal to negative 2 value, and see where the curve is at. The curve is down here. Now, remember, below the x-axis, all those derivatives are negative. All right. So if my point on the derivative is located here, that means that the y-coordinate is telling me that this is going to be a negative derivative, which means that f of x is going to be decreasing. Right? It sounds like a lot of jargon. So if all this is not making a whole lot of sense to you, you probably need to come talk to me before you take that test. All right? This is absolutely essential that you know this. All right? So because once you understand this, then everything kind of comes together really nicely. You don't have to memorize this stuff. All right? On this version of the quiz, on the bottom, this is a graph of f of x, so this is different. F of x is the greatest. Can somebody here translate that for me? If you're trying to explain, how do you find this on this graph to, say, a 7th grader that barely knows anything about graphs? Yeah, the greatest y value, or like Kennedy said, is basically the highest point on this graph, right? So that's about it, all right? What about if f prime of x is the greatest? What is, in the simplest terms you can think of, anybody in this class, what does that mean? The steepest slope, the steepest positive slope, all right, of the tangent line. And if you look at C, for example, well, first of all, this is the only positive tangent line that you have here anyway, right? The A is actually negative, and B looks like it might be a horizontal tangent, right? Now remember, if you're looking, just a little side note, if you're to do the derivative graph of this, remember that this point would be located on the x-axis on the derivative function, right? Just to kind of connect that two for you. All right, where is f prime of x the least? That means the most negative slope, which in this case I already drew it up here, is A. or the most negative tangent line. And then finally, f prime of x is equal to 0. Basically, remember, when you see this, that means the slope is equal to 0, or the slope of the tangent line is equal to 0, which would also mean you have a horizontal tangent. So all those things mean the same. So anytime you see this, make sure you can translate that in your head. F prime of x is equal to 0, that means that's a horizontal tangent, that's the same thing. Or you have the slope of the tangent line is equal to 0. All those things mean the same, all right? Now that one's going to be located up here, okay? And then, and remember that this, when you have a derivative is equal to 0, that's normally going to be, not all the time, you're going to have either a max, a minimum, or perhaps neither, okay? So for example, let me go down to this one in case you had a question. What do you guys think in this class? Is this a max, a min, or neither? Neither, right? Because remember what I said, a max has to go from positive to negative, and a minimum goes from negative to positive. This one went from negative to 0 to negative. Does that make sense? There was no sign change, so therefore there is no max nor min. You with me? This happens to be decreasing the whole time. Yes?
But it still has a horizontal tangent?
Yes. So the way that would look like, okay, the way that would look like, and I'm just going to focus on this, not anything else, is that, remember, it's always decreasing, right? So it would all actually look like a cubic function, like that. All right, because in the middle here, you would have a horizontal tangent. See what I'm saying? But you never actually went up again. You never actually did that. And if you kind of even look at it further, if I were ignoring all of this, right? That's kind of like an upside down parabola, and isn't this a cubic, right? 1 degree up from it. All right, so that's sort of how you. If you ever get that confused, just ignore everything else like I'm doing here, and then just pay attention to what's going on here, and you'll get it. Does that make sense? So that's how that can happen. That's the only way that could happen. Okay? All right, real quick on the second one, same idea. I'm just going to show you again. If you happen to have your quiz on you, you can look at it. It's just the same idea. We just switched the graphs. On this one, we are looking at the graph of f of x, and we're trying to figure out where is f of x the greatest, the least, f prime of x is the least, etc. All right, so all of this is the same idea, so I'm not going to take the time to explain all of this. It's the same concept. Same thing on here. I think I just will quickly talk about this. A lot of people were getting really confused. Again, wrote me the maximums and minimums. They kind of did sort of what I was about to do here before I realized that I was wrong. There we go. Okay, here's the minimum, here's the maximum. Remember, this is the graph of the derivative, right? And like we talked about in the past, and I'm saying this over and over, the possible max or mins, or where you have horizontal tangents, are located on the roots of this graph. All right. So again, these are the roots, and then to figure out your max or min, you have to go from positive to negative. Positive to negative, so that's a max. If you go from negative to positive, that's a minimum. Okay. Anyway, on the back. Now on the back, I did not count off the few people, or the people that have the quiz that doesn't say anything like makeup work on it. You actually have a much easier derivative here, formal definition. All right, which is actually the same one that we did on the warm up, because it's exactly the same one. So if you have any questions over this, make sure and ask me. On the test, you're really gonna have one question that is worth a lot. I think it's worth like 14 points or something like that. So you gotta be able to do this. So I'm not saying you're like, forget it, you don't need to do that. You're gonna need to do this, all right? But don't spend like 85% of your study time on this formal definition. Okay? Yes?
Is it gonna be much more complex than that? Like the
It could be. It could be, buddy. All right, did you get the makeup form of that? Or was this your equation that you had?
Yes.
Okay, well, the ones that have the makeup one actually had this one where you have to use the conjugate. So on y'all's test, I didn't actually count it off right or wrong, okay? Like I think I corrected it for you, maybe wrote an X if it was too much work. But because I felt like this question, which was significantly harder than the other one, then I just didn't count it against you. Does that make sense? So again, could it be, this is as complicated as I could possibly get. Okay, Eric? That's as complicated as I could possibly get. All right, so remember, this is not that bad. If people screwed up, they normally screwed up right here. Most people did a great job of doing this. But then after that, you kind of got lost. Remember, on the denominator of this, you're just rewriting it. You have to be careful though, right? I'm multiplying this times this times this. So I'm just going to write this times all of this bottom. That's why I have parentheses here. You with me? And then some people just got rid of the plus sign altogether, which then gave them the wrong answer, right? Do you see how you get from here to here? Right, notice that the delta x are going to cancel, right? I didn't write it on there because I don't want you to be confused, but that will cancel. All right. Now, even so, again, don't spend like 85% of your review time on the formal definition. Do work through a few of them. I did not pick up 21, so you should be able to at least look through some of your problems. Now, the ones that worry me are the ones like this, because this is important and this will be on your test. Okay. So again, we had those warm-ups, and I understand that some of you probably need a little bit more processing time before I just throw you into a test. All right. So remember that on this one, if you're looking at this, it's asking us to find f prime of 2, and I get this answer. Now, if you need, okay, somebody translate that for me. What number did I just find here?
The slope.
The slope of what?
The tangent line. Slope at 2.
Right. So combine everything you guys said. I found the slope of the tangent line at 2. You with me? So this is the slope of the tangent line for this function, okay, at 2. You with me? Now the very next thing, the reason I'm saying that is because the very next thing, what is that asking you for? They're asking you to write the equation of the tangent line at x is equal to 2. What are the two things that I need for an equation of a tangent line?
Point and a slope.
A point and a slope. I already have the x value. I need the y value, right? And I can get the y value. Remember, I'm getting the y value from this, from the original one. Okay? Now, once I have the y value, which I have it right here, do I already have the slope somewhere?
Yeah.
I already have the slope is what I found here. All right? Now, some people went ahead and tried to do the formula for the definition of a derivative at a point. Right? Remember that formula that says the limit as x goes to c of f of x minus f of c all over x minus c. They did that here, which is completely fine. I'm just telling you that you already found that. All right? Now the test is going to be very similar. So don't do the extra work if you don't have to. Okay. So that's the equation of the line. I wrote it both ways only because I wanted to see if you get it either way. And even then, okay, I could totally sort of forgive you for that. But the ones that you cannot miss are these. You just didn't know what you were looking for. Okay? If I ask you, find the value of x. Now notice, find the value of x, which means I'm looking for an x value. All right? Where f of x has a horizontal tangent. When you see that word, horizontal tangent, remember that what I'm saying is I want to know where the derivative is equal to 0. Right? Where you have a slope of 0. So that alone is basically telling you what to do. I'm going to plug that in. I'm going to set my derivative, which I found, which is actually given to me. It's not even found. It's right here. That's the derivative. Set it equal to 0 and then solve for x. That's it. Okay? Now, 13, it says, for what x value is the slope of the tangent line equal to 9? Same thing. You're going to set the derivative equal to 9. All right? Now, it's up to the ball is in your court. That's what I'm trying to tell you. All right? You need to put some work into this. This is not pre-cal. All right? This is more difficult. There's a lot of conceptual stuff you need to put together. All right? So, anyways, I'm going to stop the video now.